Hello everyone, good evening. This is Ramkan Vishwakarma and I'm going to teach a small topic, that is path of charged particle in a uniform magnetic field. So before starting this topic, I want to discuss the force on the charged particle when it is moving in a magnetic field, because we need that force to explain this topic. So basically, if I will take a magnetic field, this is a magnetic field, this is uniform magnetic field. If I want to find the direction of this magnetic field, it is basically inward into the plane, inward. So this is magnetic field. Now if I will take any charge, this is charge q, which is in magnetic field and it is moving, then the force acting on the particle, that will be q into v cross v. So if I will split this, we will get q v and the cross product is vb sine theta, and here theta is the angle between velocity of the particle and magnetic field. Now based on this force, this magnetic force or force applied by the magnetic field on the particle, we are going to discuss the different path acquired by this charged particle when it is placed in a magnetic field. So the first most important point is, suppose the case one. First point I'm taking here, this is magnetic field. I'm taking this is magnetic field which is into the plane, or inward we can say, into the plane. Now here this is the magnetic field and it is uniform magnetic field. This is what? Uniform magnetic field. Okay, so this uniform magnetic field, now I'm taking a charged particle q here, a charged particle q. Now what will happen if it is inward? If I will throw the charge along the direction of magnetic field, so what will happen? So for this I'm taking, to understand this topic easily, I'm taking the direction of magnetic field with the help of an arrow. So I'm taking here, this is the magnetic field direction. I'm taking, this is the magnetic field. This is magnetic field. Now I'm taking a charge. See, this is the charge. This charge q is moving with velocity v in the direction of magnetic field. So if you will see, the direction of magnetic field and the direction of velocity, both are in the same direction means they are parallel. So we can say the angle between these two quantity, that is 0 means what will happen? What is happening basically? So if the theta is 0, this theta is 0, then we can find the force. If theta is 0, it's not visible. Okay. So if I'm taking this theta is 0, then magnetic force, q v sine theta. So q v sine 0 degree. If it is sine 0, then we can say sine 0 is 0. So Fm, force on the charge in magnetic field, is 0. Means no force is acting on the particle. So the path of the charge will be straight line. So this is the first case number 1, when magnetic field and charge particle moving in the same direction, then force will be 0, and the path acquired by the charge particle is straight line. Straight line. Okay. So this is the first case. Now second case is I'm taking here magnetic field and velocity of the charge particle, both are perpendicular to each other. So let us draw the magnetic field. This is magnetic field I am drawing here. Okay. Now this is magnetic field which is into the plane. Now means magnetic field is inward. Now what will happen? I am throwing the charge particle perpendicular to the magnetic field. So this is magnetic field and I am throwing the charge particle Q in the uniform magnetic field which is perpendicular to the magnetic field. So here you can write a important point, that is V. If it is moving with velocity V and the magnetic field direction, that is the magnetic field, so V velocity is perpendicular to magnetic field. Now what will happen? As it started entering in the magnetic field, there will be a force. So how much force it will acquire? So this is magnetic field, force due to magnetic field, that is equals to Q V sine theta. Theta will be 90 degree. So the force Fm is equals to Q, that is QVV. So here the force acting on the charge particle when it is thrown in magnetic field which is perpendicular to the magnetic field, the force will be maximum. If force is maximum, then what will happen? Obviously magnetic field apply the force on the charge particle and charge particle will acquire a path. As magnetic field is uniform, so what type of path it will acquire? It will acquire a circular path. And as due to the uniform magnetic field, the radius will be always same. So I am taking radius is r. Now we are going to find the radius. How much radius it will acquire? What is the radius? What is the basically diameter? Means you can say how much radius it will acquire. So now we are going to precisely discuss this topic here. So again I am taking the path of the charge particle. I am taking here. This is the charge particle and charge particle is moving in a uniform magnetic field. So it will acquire a circular arc here. Now I am taking, this is the radius r and this is the charge particle whose mass is m. Mass of the charge particle is m. Now if it is moving in a circular path, a force, as due to the magnetic force it is moving, but when it started moving, a force will act towards the center of the circle. So this force basically called centripetal force, and here the velocity of the particle will be in this direction. And as we have taken magnetic field is inward and velocity is moving upward. So angle is 90 degree as we have seen. So what will happen? The radius of the path is not changing, means this centripetal force and force on charge due to magnetic field will be equal. So here force due to magnetic field is equals to force centripetal force. Now magnetic force is what? Maximum, as it is angle is 90 degrees, so magnetic force is maximum. So here I am writing Q V V, that is equals to m v square by r, that is the centripetal force. Now here what will happen? This r, this v V will get cancelled, then what will happen? R will be is equals to mb by qb. mb by qb. This is the radius acquired by the charged particle in a uniform magnetic field. But as you know, charge has mass. It is moving with some velocity. Means it has momentum, it has kinetic energy. So that part, how we will find radius in terms of kinetic energy? As you know, this mb is equals to what? mb is equals to momentum. Momentum is equals to mass into velocity. So we can replace it. R is equals to mb means P divided by qb. And one more point, we know the relation between momentum and kinetic energy. So momentum and kinetic energy relation is what? P is equals to under root 2m k. K means kinetic energy. So we can replace it with the P. So R is equals to, here I am writing, R is equals to under root 2mk divided by qb. Now finally I am writing. Now see carefully, this is kinetic energy basically. Okay. Kinetic energy means, see carefully, if I will draw here one more formula we can derive it, like if you know, since potential difference is equals to work by charge. Potential difference is equals to work by charge. Now work is equals to what? Potential into charge. This work will store as an energy. Which energy? As body is moving, energy caused by the body by virtue of its motion. So that is kinetic energy, and that is equals to V into Q. So final R is equals to what? R is equals to, we can write K, at the place of K we can replace it. So R is equals to under root 2m, K is V into Q divided by Q V. Okay. Now, so I will summarize all the formula at one place here. Now, now see carefully. R is equals to mb by qb. That will be is equals to p by qb. That is equals to under root 2mk by qb is equals to under root 2mk. At the place of k we will replace with v into q, that divided by q. So this is basically radius acquired by the charged particle when it is moving in a uniform magnetic field and it is perpendicular to the magnetic field. So these are the radius. Now if it is moving uniformly, means it will have time of revolution, and it will have angular velocity. So how we will find? As we know here, I will erase it. So here we know that time period of revolution, time period is equals to what? Time period, circumference of the circle. Or simply we know that time is equals to distance by velocity or distance by speed. So distance means circumference of the circle. So here I am writing 2 pi r divided by b. 2 pi r divided by b. And what is the value of r? So let us put here. So r is equals to mb by qb divided by here it is b. So v will get cancelled. So what we are going to get here? So this is, here I am writing, this is t is equals to 2 pi m by qb. 2 pi m by qb. This is time period. And the next one is This is first, this one is second, here I am writing third. So next is angular velocity. So angular velocity. Angular velocity omega is equals to what? Omega is equals to what? Angular velocity omega. Omega is what? 2 pi by time period. 2 pi by time period. So omega is equals to 2 pi by t is how much? 2 pi m by qb. It will go up. So 2 pi cancel. So omega is equals to qb by m. qb by m. This is basically what? Angular velocity. Now one more small point is here. The fourth formula. Fourth one is what? Frequency. Obviously, if it is have time period, then it will have frequency. So frequency is equals to 1 by time period. So 1 by time period means this will become qb divided by 2 pi. This is frequency, and this frequency also known as cyclotron frequency. Okay. So these are the second case. This is second case. Now then third case, let us discuss the third case. If you will see one more important point here. If you will see, this is frequency, this time period, and this angular velocity is not depending on the speed of the charge particle. Not depending on the speed of the charge particle. Based on that, we have many questions in JEE Mains and NEET also. So here, next part I am going to discuss, that is, if the charge particle is thrown in magnetic field, with some different angle, some other angle, means if case 3, if theta is other than 0 degree, 90 degree or 180 degree. If theta is other than 0 degree, 90 degree and 180 degree, means some different angle we are throwing the object. So let us take magnetic field. So here I am taking magnetic field. This is magnetic field. This is magnetic field V. Now what I am doing, I am taking the charge particle here. This charge particle I am throwing at some angle. If you will draw it, so suppose I am taking, this is x-axis, this is what, y-axis, and this is I am taking a z-axis. So what will happen? I am throwing this charge particle at some angle. At some angle means I am taking, this is the angle theta. As we are throwing this at the angle theta, when it will reach in the magnetic field, it will acquire a different path. Basically, this is called helical path. It will acquire a helical path, or it is also known as helix. So who is responsible for this helical path or helix path? So here I am taking, this is basically velocity. This complete velocity is not responsible for the path acquired by the particle. So who is responsible? So I am going to split this velocity component into two parts. So if you will observe clearly, this is the component of velocity which is parallel component. And this is one perpendicular component. Parallel component means parallel to the magnetic field. Perpendicular component means this velocity of the particle is perpendicular to the magnetic magnetic field. Means here we can say parallel velocity is v cos theta and perpendicular velocity component is v sin theta. V cos theta and v sin theta. So what is the path acquired by this charged particle? That is helix. Then what will be the radius of the helix? So radius of the helix is r is equals to, as we have find it, mv by qb. This is mv by qb is the path acquired by the charged particle in uniform magnetic field when it is placed perpendicular. Now what will happen? This path is acquired by the acquired by the perpendicular component, not with the parallel component. So we will replace it with perpendicular component. So r is equals to what? mv. V perpendicular means how much? V sin theta. This is v sin theta divided by qb. This is the radius acquired by the. Now one more important point is there, that is called pitch. Pitch. What is pitch basically? Pitch means the path or distance covered by the charged particle along the magnetic field, in one revolution. So path distance basically. Pitch means what? Pitch means basically distance, and distance is equals to, velocity. So this is basically distance is equals to speed by time. So distance is speed is equals to distance by time. So distance is equals to speed into time. So this pitch will be is equals to speed into time. So here speed is which this path is acquired by particle by which component? By parallel component. So here I am writing v parallel into t. So here p is equals to, what is v parallel? Here v parallel is v cos theta into time period. Time period we have calculated just before. So this is what? 2 pi m by q. So this is basically what? Pitch acquired by the or path covered by the particle. So these are the topics. This is the topics of charged particle when it is moving in magnetic field and it is acquiring different path. We have seen the force acting on the particles, that is Fm is equals to Q V cross B, and that is QB V sin theta, and we have taken the different path for the charged particle when throwing along the magnetic field. The force will be 0, then the path is a straight line, and if the particle is thrown perpendicular to the magnetic field, then the charge will acquire a path which is uniform, which is circular path, and with the help of that path we have calculated the radius, time period, frequency. These points we have calculated, and the last case when the angle is some different angle other than 90, 0 and 180. So we are getting helical path. For the helical path we are getting radius, that is mv perpendicular divided by qb. Perpendicular is v sin theta we have placed, and then this is pitch. Pitch means path covered by the charged particle in the direction of magnetic field. So these are the particles. So thank you everyone. Thank you so much.